Here is a sample problem-solving question on non-disjunction, where you have two parents with a child, and the child is missing a chromosome. You're trying to figure out which parent non-disjunction occurred in during the production of gametes. The question states, in humans, hemophilia A is a recessive trait carried on the X chromosome. Imagine that a couple, Mike and Anisha, have a daughter with hemophilia A with the unusual karyotype of 45X. Anisha's maternal uncle also had hemophilia A. Where could an error in meiosis have occurred that would have given rise to this daughter with only one chromosome who has hemophilia A? So let's start by drawing our pedigree. Anisha is shown with a circle, Mike is shown with a square, and they have a daughter with the karyotype of 45X. So this would be Turner syndrome. It's the only survivable human monosomy, and this daughter is missing the other sex chromosome. We put a star on it because she has hemophilia A. We know that that X chromosome has the hemophilia mutation. So let's draw Anisha's side of the family. This is Anisha's mother and father, and the question states that her maternal uncle has hemophilia A. So that means the uncle on her mom's side, and these are Anisha's grandparents. So we can label the genotype of the maternal uncle that has hemophilia A, and we know the genotype of the maternal grandma that she would have to be a carrier. Now, Anisha is likely to be a carrier as well because the daughter has hemophilia A, has a mutation on the X chromosome. Mike does not have hemophilia, so he's probably XY. And so it's okay for us to make an assumption here that Anisha is a carrier. So to answer this question, we need to look at Anisha's gametes and Mike's gametes and predict what they could be. So it's likely that Anisha's gametes are probably X and X with hemophilia, and Mike's gametes are probably XY. These are the gametes they produce in meiosis. But there has to be a mistake somewhere because the child is missing a chromosome. Well, the child has an X chromosome with hemophilia. So in terms of contribution to the child, Anisha's gamete contributed an X chromosome. And so what this means is that the mistake in meiosis must have come from Mike's gamete. So Mike produced a gamete wherein the X or Y chromosome was missing because of non-disjunction. Now, we don't know if this happened at meiosis 1 or meiosis 2. It could have been either. However, we know that non-disjunction occurred in the production of gametes in Mike.